Okay, in this video, we're going to try to summarize the key types of questions that you get asked about the hydrogen emission spectrum topic and what type of marks will be accepted on the mark scheme for a test. Okay, so we began this topic by talking about emission spectra in general, comparing a continuous spectrum that contains all the wavelengths with a line spectrum that you see with hydrogen. So that's called the hydrogen emission spectrum. So the first type of question has to do with simply describing what the hydrogen emission spectrum looks like. We'll come back to that. Second, we got to a point where we could try to explain what was happening, what was creating these lines, this particular line spectrum. So one question is to describe what it looks like, and a second question is to try to explain where those lines come from. We talked about electrons. We talked about electrons absorbing energy and moving up in energy levels, and then jumping back down in energy levels and emitting electromagnetic radiation, and that's where the lines come from. Electrons jumping down in energy level, emitting electromagnetic radiation of very specific energies, which is why we see very specific colors, lines of color. We talked about how jumping down to the second energy level is the right amount of energy to release visible light. So these colored lines, the ones in the visible part of the spectrum, are only created by jumps down to the n equals 2 level. And the lowest energy jump gives us the red line because that's the lowest energy kind of visible light that I see in this line spectrum. The red is the lowest energy color of light. So the jump from 3 to 2, for example, energy level 3 down to energy level 2, emits this red wavelength of light. Whereas a jump from 4 to 2 releases the kind of light bluish green line, and the jump from 5 to 2 releases the dark blue sort of purple line. And then the jump from 6 to 2 would release the next line. So they're all jumps down to the n equals 2 level. That's what emits visible light. And the electrons are jumping from very specific energy levels, which is why they can only emit very specific energies of light. So that brings you to like the Bohr model of the atom. Looks something like this. Now, it's not going to be entirely correct, this idea of electrons traveling on these perfectly circular orbits, but the concept of electrons only existing at distinct energy levels that we call n equals 1, n equals 2, n equals 3, and so on, those are the possible energy levels for the electrons, and those energy levels get closer together the farther away from the nucleus we get, and the higher in energy that we get. So that's the Bohr model of the atom. We talked about drawing energy level diagrams where we show increasing energy on the left-hand side, and we represent the energy levels as just horizontal lines that we label n equals 1 at the bottom, up to n equals 2, 3, 4, 5, 6, and ultimately we get to infinity. So n equals 1 represents the first lowest energy level, and then 2 and 3 and so on. And key thing to show is that as we go up in energy, the energy levels keep getting closer and closer together. They are converging. Eventually you draw the n equals infinity. Since they can never actually get to infinity, n equals infinity represents just beyond the outermost energy levels of the atom. So it represents just outside the atom. The only time we need to use the n equals infinity is to illustrate something called the ionization energy, where the electron is taken from the ground state out to infinity, to beyond the atom, where the electron is removed from the atom. But I'm getting off of my main topic here. To summarize the three main questions that you get about the hydrogen emission spectrum, the first one is describe the appearance of the hydrogen emission spectrum. So this question is simply asking you to say, what does it look like? You guys have all looked through the spectroscope at this point and seen the colored lines that we know hydrogen is giving out when it's put into that glass tube and excited with electricity. So this question, we just need to give 2 marks to explain what it looks like. It is a series of discrete lines of color, and those lines converge at higher energies. That's simply what it looks like. We see red, we see green, we see purple, or kind of light blue and purple. So we see a series of colored lines, and the colored lines get closer together as they go towards higher energy. The purple light is higher energy than the blue light, and then the blue light is higher energy than the red light, and the blue and the purple are a lot closer together than the red line is. So this is only talking about the lines. It's not attempting to explain where those lines come from. That would be the second question. Second possible question about a hydrogen emission spectrum is to explain how the hydrogen emission spectrum is created. So now you have to talk about electron transitions. So you can talk about electrons absorbing energy, because obviously that needs to sort of happen first. It might be something that's sort of in parentheses on a mark scheme, like it may not be essential for the mark, but we can describe it here anyways. And this question on the mark scheme is often says 3 max. That means there may be more than 3 things that you can say, but you can only earn up to 3 marks. So electrons, first thing, let's establish this. Electrons can only exist at specific energy levels. That's the first thing. Okay, electrons can absorb energy and jump up in energy level, or they can transition up, but that they move up to a higher energy level. So we could say jump up to a higher energy level. Electrons jump down. Now, this question is about the hydrogen emission spectrum. When they say that, we're really talking about the visible emission spectrum. So the best thing to say in this part of the answer is that electrons jump down to lower energy levels and emit electromagnetic radiation. That means they're emitting light. But the part about the visible, we're going to have to at some point say that electron transitions down to the n equals 2 energy level emit or release visible light. So you could probably just combine the previous 2 bullet points saying electrons jump down to the n equals 2 energy level and emit visible light. But more generally, the idea is that electrons jump down to lower energy levels and emit electromagnetic radiation. When they jump down to 1, they release ultraviolet. When they jump down to 3, they emit infrared. So they emit different types. If we're talking about the hydrogen emission spectrum, we're really talking about the visible emission spectrum. So at some point, if they talk about visible, you're going to have to say the n equals 2 energy level, because that's the one that they jump down to when they emit visible light. Okay, what else do we have to explain? There are other things that we could say. Why do the lines get closer together at the higher energies? Well, that's because the energy levels themselves are getting closer together at higher energies. So as the electrons make bigger and bigger jumps, the differences between those jumps are getting smaller. So electrons transition down to n equals 2 to emit visible light, and the energy levels converge at higher energies, or farther from the nucleus. So that's pretty much a point in all of these different questions, is getting at this convergence idea, which is really key. I can even think of one more thing that might be on the mark scheme, which is that the energy released is equal to the energy difference between energy levels. So on the previous page, I was talking about how the red line is emitted when the electron jumps from n equals 3 down to n equals 2. So if we calculate the energy of that red light, it will tell us the exact energy difference between n equals 2 and n equals 3. So the energies of those colored lines can be used to learn exactly how far apart the different energy levels in hydrogen are. So I've listed a whole bunch of things as possible marks. Let's see. If we're going to go and say, probably these ones are maybe not on the mark scheme. Those first 2, they're a little bit more, they are accurate, they are part of the explanation, but really the part that explains where the lines are coming from is the jumping down from higher energy levels to lower energy levels. That's what involves the emission or the release of energy, of electromagnetic radiation. That's important, the idea of moving down. Second, the idea of going down to n equals 2 is important if the question wants to know about visible light, because that's the energy level where they release visible light. The idea of convergence is very important at higher energy and farther from the nucleus. And we can say that the energies released are equal to the energy differences. Lots of different marks here to earn 3. Finally, the third type of question is explain the model of electron configurations from the Bohr model that was determined from the hydrogen emission spectrum. So this one is less about explaining or describing the colors of light and instead saying, what does this tell us about electrons in the atom? Well, we learned from the emission spectrum that electrons can only exist at distinct energy levels in an atom, right? That's the first key idea. They can jump between them, they can transition between them, but there are only certain energy levels where the electrons can exist. And the second thing that we learned about those energy levels is that the energy levels converge at higher energy or farther from the nucleus. So the farther we get from the nucleus, the closer together they are, and the nearer the nucleus, the farther apart they are. And that's really it. If this is a 2-mark question, those are the things that we learned from the Bohr model. Now, you could say other things we learned, like that electrons can absorb energy and jump up, and they can drop back down and release energy. But this is just wants to know about electrons in a normal atom around a nucleus. What the Bohr model taught us, or what the Bohr model says, is that electrons can exist at certain energy levels, and those energy levels are farther apart near the nucleus and closer together when we get far from the nucleus. That's it. So it's actually a really simple question to answer. But you can see, because there are 3 different typical questions on this topic, you have to read really carefully for what the question is actually asking you to answer, and then answer accordingly.